Today we're going over 5.1 modeling data with quadratic functions. So standard form for quadratic functions is going to be y is equal to ax squared plus bx plus c. And that's standard form of a quadratic. And you know that it's going to be a quadratic when it has ax squared or anything with x squared in it. So therefore, this entire term is going to be the quadratic term. Your bx is going to be the linear term because it's just x to the first. And if you're going to graph something that has the highest degree of x, then it will be a line. So this will be a linear term. And then c, since that's just going to be a number and we're not multiplying it by x, it's going to be your constant term. So those are all of the terms of a quadratic function. So let's do a problem where we have to find what the quadratic equation would be when they're giving us 3 different points. So the reason why we need 3 different points is because there are 3 unknowns. A, B, and C are our 3 unknowns. So let's take this chart right here and we're going to find the quadratic function using these 3 points. So we have the points 2, 3, 3, 13, and 4, 29. And what we're going to do is we're going to plug them into our standard form here. We'll plug in y and we'll plug in our x, leaving a, b, and c, our 3 unknowns. So if we have 3 unknowns, you need 3 equations. So let's go ahead and plug these in. 2, 3, we'll plug in 3 for our y. We have a, then we'll plug in our x. Our corresponding x would be 2, so 2 squared, plus our b times our x value, 2, plus c. We'll plug in the next point here. We have 13 is equal to a times 3 squared plus b times 3 plus c. And our last point, 29, is equal to a times 4 squared plus b times 4 plus c. Now we can go ahead and clean that up a little bit. So we can write this as 3 is equal to, 2 squared is 4, so that's a 4a, plus 2b plus c. Clean this second equation up. 13 is equal to 3 squared is a 9a plus 3b plus c. And then our last equation here is a 29 is equal to 16a, because 4 squared is 16, plus 4b plus c. So we got these equations by just cleaning this up a little bit and doing whatever operations we needed to. Alright, so next we want to look at our 3 equations and eliminate a variable so that we can get it down to 2 equations and 2 unknowns. So let's go ahead and label these equations. This will be equation 1, 2, and 3. So if you notice, we need to get opposites. An opposite, for example, is 2 and -2. Those are opposites. And when you add opposites, you always get 0. So if we have c, then the opposite of c is -c. So we have c, and we need to get a -c in order to add the equations and eliminate them. So you can either subtract equations, 1 minus 2, or you can multiply everything by a negative and then add them. That's really up to you. So let's take equation 2 and subtract equation 1. So So we have 13 equals 9a plus 3b plus c. Now we're going to subtract equation 1 here. Minus 3 minus 4a, 2b, and c. Make sure you put the parentheses around this so that you know you're subtracting every term. So you have 13 minus 3 is a 10. 9a minus 4a is a 5a. 3b minus 2b is a b. And then c minus c will be eliminated. Let's call that equation 4. And now we have variables a and b in here. So we didn't use equation 3 yet. So we know we have to use equation 3. And now we can use either equation 1 or 2, and that's really up to you. So let's use equation 2. We'll do equation 3 minus equation 2, and that's because c minus c will be eliminated. And again, we'll end up with the same two unknowns, a and b. So we'll write those down. We have 29 is equal to 16a plus 4b plus c. And then we have minus, we're going to subtract equation 2 here. 13 is equal to 9a plus 3b plus c. Now we'll subtract them. 29 minus 13, that's going to give us a 16, is equal to 16 minus 9 will give us a 7a. 4 minus 3 will give us b. C minus c will be eliminated. We'll call that equation 5. So now we have two equations with two unknowns, the same two unknowns, a and b. So what we're going to do is we're going to either eliminate a or b. So in this case, it's going to be easier to eliminate your b because we can just subtract the equations. So we could do equation 5 minus equation 4. Because b minus b will cancel out and we'll eliminate the b's. So minus 10, we have 5a, and we have b. So we have 16 minus 10 will give 6. 7a minus 5a will be a 2a. B minus b eliminates. Now we have finally one equation with one unknown. We divide both sides by a 2, and therefore a is equal to 3. 6 divided by 2 is 3. So now we have a is 3. We're almost there now. We can plug into either equation 4 or 5 to find b. So we'll do that. We're plugging in a to be 3. 10 is equal to 5 times 3 plus b. 10 is equal to 15 plus b. Subtract 15 from both sides. And we get b is equal to a negative 5. So now we have a, we have b, and finally we will find c with one of the original equations we started with. So we can use equation 1 here. So equation 1, we're going to plug it in. We have 3 is equal to 4a plus 2b plus c. So we have 3 is equal to 4 times a is 3 plus 2 times b, 2 times negative 5, and then plus your c. Let me just rewrite that. 4 times 3 plus 2 times our b is negative 5 plus c. So we have 3 is equal to 12 minus 10 plus c. 3 is equal to 2 plus c. Subtract 2 from both sides. And c is equal to 1. Now that we have a, B, and C, we can plug it back into our standard form and get y is equal to 3x squared minus 5x plus 1. And that is our form for the quadratic function that goes through these 3 points.